How is Delta V used to deorbit satellites safely? Imagine a satellite that has finished its mission and needs to leave its orbit without causing harm or adding to space junk. How do we make that happen smoothly? The answer lies in a concept called Delta V, which is a fancy way of saying change in velocity. It's like giving the satellite a gentle push to slow it down or change its path. Delta V measures how much speed a satellite must lose or gain to perform different maneuvers. For deorbiting, it's all about slowing the satellite down so it drops from its current orbit toward Earth. When a satellite is in low Earth orbit, it travels very fast, about 7.5 kilometers per second. To bring it down safely, mission planners calculate exactly how much Delta V is needed to lower its orbit enough for reentry. The process begins with figuring out the total Delta V required, called the Delta V budget. For satellites in low Earth orbit, this usually ranges from about 20 to a few hundred meters per second. The amount depends on how high the satellite is and its current speed. Once the Delta V is known, onboard propulsion systems like chemical thrusters or electric propulsion are used to apply this change. Chemical thrusters provide quick bursts of thrust, while electric propulsion offers a steady, efficient push over a longer time. The key is to carefully plan the maneuver so the satellite re-enters over unpopulated areas, avoiding risks to people or property. The thrusters fire in the opposite direction of the satellite's travel, reducing its velocity. As the satellite slows down, its orbit shrinks and its perigee, the closest point to Earth, drops into denser atmospheric layers. This causes drag, which helps the satellite descend further and burn up during reentry. Sometimes, satellites are moved to a disposal orbit or graveyard orbit, especially if deorbiting is too costly or complicated. But for low Earth orbit satellites, the goal is to use Delta V to bring them down within about 25 years, following space debris rules. Electric propulsion systems are increasingly popular because they use fuel more efficiently, allowing for a smaller fuel load and longer-lasting maneuvers. Applying the right amount of Delta V is essential. Too little, and the satellite won't re-enter. Too much, and it could cause unintended consequences. By precisely calculating and executing these maneuvers, space agencies and operators can safely remove defunct satellites from orbit. This process helps reduce space debris, keeps the environment safer, and ensures future space missions can proceed without unnecessary hazards. Delta V management is a vital part of keeping space sustainable and protecting our orbital environment for years to come.